Hi everybody, it's Kent here from Plugins 4D. Today I'm going to take you through the updates to Jet Fluid. Now, since I did the last video, there have been two updates, a version 9 and a version 10, or 0.09, 0.10. And today what I'm going to do is take you through the updates first, the new stuff in 10, and then I'm also going to show what was actually updated in version 9 as well. And so let's just jump in here, and I'm just going to delete this. This was just my test scene that you've probably all used if you've ever used Jet Fluids. Under Plugins 4D, Jet Fluids menu, I'll just break that out and I'm going to just dock that across over here. So the new thing that we've added here is the ability just to add everything from the scene. So if I just add a scene, now before you would have added that test scene and added a few things here to get started. So I've decided to take some of these features across into just the scene itself. So now you've got the scene, you can easily add one of the solvers that you want. Now this was already there before, the level set and the smoke and flip. If we have our scene here, we've got a level set solver, and so that's the simulator, the solver that we're going to use. And if we want, we can add one dam brake, and then I'll put that on the side there. Two dam brakes. Now this is just going to be water and these are just emitters, and they'll just go down and collide. You got a pouring liquid that'll pour down from that side. Two pouring liquids that will intersect when they hit. The jet framework test scene. Now this is what is shown by all the examples in the jet framework book. And if you want to do the test scenes there, you can just add that, and you can use all the different solvers here, and you can see how it works there as well. You can add a quarter fluid. Now I use this quite a lot. If I have a quarter fluid and I add a sphere, then I can just have a simulation running. So any of these, you just add them, and then you just click your solver, and again you start caching, and then you'll start simulating your fluid. Now something else that you might want to do while you're doing your simulations, you might want to hide all the emitters. So I added options to hide all the emitters, and you can show them again. And also hide the colliders. If you've got colliders in your scene, you want to hide them, you can hide and show. Now just note that if you hide colliders, they are still being picked up, and as well as emitters. If you hide the emitters, they still will keep emitting. So you can do that. Now you can see the fluid there, and we can just play that one back. So that was a quarter fluid and the sphere. And I'll just clear that cache, and I'll simulate some of the other ones while we're here. So if I go back to my scene, I'm going to delete what's in there, and I'm going to just add the two pouring liquids, and I'll click the solver and start caching. So this is being done on a 10-core i7 machine. It's about 5 years old now, so it'd be interesting to see how this performs on some machines that have a lot more cores. And this is the level set fluid, and it's just the standard 200, 200, 200 with a cell size of 4, which means that there's effectively a voxel grid of 50 by 50 by 50, and that's the speed you can get. Now, if ever you are having problems and Cinema 4D might be crashing, it's most likely related to these updates being live in the viewport, which is why there's this live viewport previews. So if you do encounter crashing because it's trying to update in viewport, you can turn that off. But I have made improvements to this as well. Previously, you may have noticed while you're rendering, this may have been jerky, or it might have disappeared and popped in the viewport. So I've fixed that, so now it will always show in the scene. And if you want, we can now play that back and see the fluid. So if you don't want two fluids, the other option is the one fluid, and of course there's the dam brakes, which are useful if you're wanting to put objects in there. Now these buttons here, they work with the size of the solver as well. So if I just delete those, and if I was to make my solver longer that way, and now I clicked on these buttons here, you'll see the two dam brakes. It puts them at I think that's like a third, or it might be a quarter of the size on each side. Similarly, it does the same with that. I may change this to not have those resized in a future build. It's just showing that there because that was the previous cache that we had before we resized it, so I can actually clear that. Another option here that we've added is when the scene is selected, and if you're wanting to change solvers, because sometimes you might want to have the same setup but use different solvers. So if you have your solver set up, let me just change this to, say, a cell size of 5, and this is just to show an example. And now I add another solver, so I added the flip one. So now if we click on flip, you'll notice that it keeps the cell size and it retains the same dimensions. So now there's a flip and a level set using the same space. So if I was to bring back some one of these, let's put the sphere in the scene. Now I can click on this one and I can simulate that if I wanted to. And then if you want to do a comparison with some of the other simulations, now you just go up to that one you want and you can just start caching that one. This is actually showing both in the viewport at the same time. And then if you want, you can just drag one across and now you can play them both back if you want to see them side by side. Bearing in mind here that right now I'm internally caching both of these, so if I was to save the C40 file, it would be quite large. So if you're really wanting to do this and compare multiple, make sure that you use external caching and cache out to a file on disk, multiple files on disk, one per each frame. So that about covers this scene here. But you'll notice two other things have been added since the version 9 version, SPH and PCI SPH. Smooth particle hydrodynamics, and I think it's a bit of a tongue twister. It's predictive, corrective, incompressible smooth particle hydrodynamics. Let's just call it PCI SPH. Now, these can be used as well. Now, the issue with them here is that the SPH can be quite unstable, but the PCI SPH is a bit more stable. I've just added these, and it's only got the very basics of features in here. So let me just show what you can do. So if I add, let's just do PCI SPH for now. If I was to add, say, a sphere in here, and now let's simulate that one. So you can see that simulating in the box there. And if I was to clear that, let's just play that back and see how that looks. Oh, I cleared it. Let's just simulate that again. I'll just stop it there, and I can play that back there. And that's how the PCI SPH works. And now let's do the same thing for SPH. And again, we're simulating within this box. It's using the domain of the box, just like all the other solvers. And let's click SPH and click Start Caching. And we'll stop it. And I'm just going to hide the PCI. I'll actually move it out as I did before. And if we just have a look, you can see that it gets a lot of force and it's scattering itself all over the domain. So I haven't looked into that and tried to fix that yet. But you can see the other ones, it's a lot more stable. Now what we can do here is we can actually, because it's intersecting this very small bounding box here, you could either make the bounding box very large and that would help as well, or you could actually even remove it. So there's a checkbox on both of these. You can see that one and that one. It's called Use Bounding Box. If we uncheck that, I'm going to do it on the other one as well. So these are no longer using the bounding box. It's still being displayed. I may remove that later on in a future build. Might get rid of the display here. And if I was to now, let's delete. I will leave that sphere in, but I'm going to clear the caches on both of these. And I'm going to duplicate that and bring it over here. Now, just to show really how this works, I'm going to grab both of those and move them completely out of the boxes. So these two solvers do not even need to be bound to boxes. And I'm going to now grab a cube, and just to give some of these, just to give this simulation something to intersect, I'm putting it underneath both of them. And now I'm going to drag that into my scene, and I'm going to add a collider to it. And now first let's grab the SPH, PCI SPH solver, and we're going to start caching. Let me just have one emitter. And now I'll do that again, clear, start caching. So you see it's not in the box at all. It's not in these domains, and it's just purely interacting with whatever colliders you have in your scene. Just note that if you want to have these collider shapes, they should have thickness. So you can't put like just a thin polygon on it. You need to give it some thickness. You can do that with the cloth collide. You can add thickness with it using that technique if you're familiar with that. Now this was just doing that was just a single shot of liquid. If I bring this up, make it a bit more interesting, I will do a couple of other things here. I'll add my redraw is not going too well there. I'll add another cube just here, just to give it a little bit of something a bit more visual, and I will put that in the scene as well and add a collider to that, and select the PCI SPH as well, and I'm going to start caching. Now it's interacting with the cube there, but if we select that and change it from one shot to constant and start caching, it's going to pour out a continual amount of liquid. Now what you're seeing here on screen is the particle preview. So something else that we've also added here, I'm just going to stop that from simulating now. One thing that I've also added is the ability to change this preview size. So this is using the fake particle method from the display tab, which is these particles right here. And you can change this particle size to, you can go up to 30, but you can boost it past that if you really want to 50. And just lets you change the size of the viewport. I think in S24 they've actually added a default larger particle size anyway, but I decided to add this slider so that anyone from R20 upwards can also change the size of these particles. And this is just for previewing. If I was to render this right now, you won't see anything. Now to help with that, you can still use the thinking particle method, which is outlined in one of my other videos. But I also decided to create a button to just put spheres in your scene if you want to just render spheres. So if you click this create multi-instance for rendering, it will set up a multi-instance in your scene, and in that multi-instance it's going to reference a sphere, and that sphere is underneath this particle null that's been added, and this particle null is hidden from the renderer and the viewport. But it is, the sphere underneath it is linked. It just means that the sphere is in the scene, but that's not going to come up while you're rendering it. But it's used, and here is the reference. And you'll notice there's nothing in source position there. Now the reason there's nothing in there is because this is going to drive it. Although that wasn't linked. That should be linked. I'm clicking on the wrong one. There we go. PCI SPH. You see that this multi-instance is linked to that. So this is going to control that. And it's not going to show anything in the viewport right now because I have set that to off. Let me just turn off the fake particles. And under here, if I change this viewport mode to something like points, you're going to see the points. And you can change it to matrix as well, and you'll see these kind of cube looking things. Bounding box as well, if you want to do that, and it'll be the smaller point size. Now these points are not being affected at all by that slider that I just mentioned before. That slider is purely just for this visual of the fake particle. And the last option under there is object. Now, never, ever, ever enable this. If you've end up getting hundreds of thousands of particles in your scene and you turn this off, Cinema 4D is effectively going to grind to a halt and stop working. So, and you'll have to, hardcore shut it down. It just can't handle it. So, if you do ever change this, then, just those first ones, matrix seems to be quite responsive in my testing, but don't use object. But it's better to actually just leave this off. Okay, never even use it. But now if I hit render, it's going to get those spheres and it's going to render them because it's going to be using it. So we'll just change this to be a little bit bigger. Let's make it 4, and if we render that now, you're going to see the spheres in the scene there. Now, not everyone likes to see spheres. It's not obviously fluids if you wanted to do fluids. So the other option here is to change, before you cache, you need to change this display type. I know it's a bit confusing calling it display, but you change that to volume. But before I do that, I'm going to clear my cache. And now I'm going to go to display. I'm going to change this from particles and change that to volume. Now everything grays out there, you'll see. I'm also going to delete this from my scene. And now when I start caching, it's going to create an open VDB volume. You can see it growing there, the green boxes. I'll just stop that there. Now that you have this volume here, you want to make it look like fluid. So from R20 upwards, they all have the volume builder and mesher. So you can try putting those in, and all you do is make the solver a child of the volume builder, and that just allows you to The only reason to do this is to allow you to do something like the dilate and the smooth. So before I do that, I'm going to put the mesher on it and place all of this under a mesher. Now this is going to make it slower, obviously, but there you can see the fluid there. And if you're wanting to kind of make it look a bit better, you can come up to the builder and maybe dilate that a little bit, and then you might want to smooth it a bit as well to get a kind of liquid look if you're wanting that kind of look. So this is all showing the PCI SPH. So I'm just going to delete that now and just show what this would look like for SPH. So here I'm going to start caching on SPH, and that's looking like it's just exploding. This one may not be much use, but I've added it in because it's part of Jet Fluids and I wanted to test it myself. So SPH is there, but if you're going to do any testing or messing around with this, the PCI SPH is the way to go. And just make sure that if you're wanting to test things like I've shown here out of the domain, that you need to change this bounding box. Now, one other thing to note here is there's some other settings here. Now, I'm not really going over them much at all. The one that is most useful is if you're effectively wanting more particles in your scene, then you can decrease this number, and you can decrease it by a point amount as well. So 5.5 might be your spacing, and that tells the algorithm how many points to create within this volume, within this sphere. It'll create more points effectively. It's like cell size, and I'm actually using the same number here to create the OpenVDB. So if you have a value of 5 here, then the OpenVDB cell size is going to be 5 as well. So this may change. Well, this will change in future. I'll be adding more options, and I'll make this a lot easier to understand and use. Now, while we're looking here, we can see a couple other things might have changed. So all of these solvers have gravity on and gravity. I've also changed these so that you can animate these. So you can now animate whether gravity is on or off, and you can animate the location of which direction the gravity is pointing. So that's available to all the solvers. So that's just a way to apply a general force and change that on the fly as you're animating. Now, the thing that's been added in version 9, one of the big things is the ability to use different kinds of forces. So right now I've got a force here which is applying gravity, and that is just coming in from the main object tab. So it's using gravity there. So if I just turn that off, then there's going to be no gravity in the scene, and this liquid, if I was to clear that cache and start caching, it's not going to do anything. It's just going to sit there and not move. So what we want to do is add a force to it. So you can actually use, for the level set solver, you can now use objects to emit a force. This is just for level set solvers. If I was to add an emitter to this sphere, Jet Fluids emitter, and I'm going to place, well, let's first resize it about there, and I'm going to show the other one in the scene. And I'm going to put the sphere, the force, right in the middle of this other sphere. So this second sphere with the emitter, and I'm going to rename it to force, and we click on that emitter. What we can do here is enable this force only, and what that's going to do is that's going to say that this is not emitting particles or volume. It is just purely going to emit a force within this sphere. And to make that do anything, we need to enable it to actually give out a force. But what we want to do here is just do a custom initial velocity, and I want it to be in the direction going up the y-axis, and we'll give it a value of, we'll just play around 12. Now I've made these animatable as well, so you can animate this force object in your scene. I previously done renders. I haven't got any here, but you could do something like a pulse, and you could have a sphere moving through underneath water, and it could put a bubble of force going up to make it look like hot balls, for example. So here we have this force, and now we're going to just hide everything. So I click scene, I'm going to click hide emitters, and now I'm going to start caching. we've got the gravity turned on, so I need to stop that. I need to go to Object tab, Disable Gravity, clear that, start caching. And now you see the force has been pushed up from the middle there. And that was just a single shot force. So that was one shot from the center of that sphere. So you can see it's just in the middle and it's just doing a shot upwards. So some of this down the bottom is not being affected, but majority of inside here is getting a big push upwards. If we want to see how that looked, let's just clear that and let's just make this one X-ray so we can see. So there's the internal sphere, and it gives roughly that amount of force upwards, which in turn would drag the resulting sides of the other fluid upwards as well, because it was in basically zero gravity. Now, in addition to these force objects, so these are force emitters, sorry. So these force emitters are only available for the level set solver. So this option will not do anything for any of the other solvers at the moment. On level set, you will not only get the ability to use emitters with force only, but you can also have forces using fields. Now, in the previous version 9, this was called fields. I've renamed that to forces in version 10. And what you can do is add a field, and that field will be multiplied against the strength multiplier. Here it's just gravity, and that will apply the force. I've shown a few examples where I might be able to bring them up actually. So here I've got a rotating linear field. So the fluid is static, and then this just spins around to make that fluid fly around. And if we look at the level set solver under force, you see a linear field, and then I'm just actually rotating that around. And here's a fun one. It's using a radial field within just basically a quarter box of fluid, and it's just churning it up using a radial field. So we've got the force. It's actually using a strength multiplier of 1, and then it's just got a start angle, end angle 360. And that just applies a rotational force, which will churn it around. And we create a brand new one. And I'm just also going to, I'll get rid of that sphere, but I will add the quarter fluid, the fields menu here. And if I just grab that and click radial field, it'll add it to the center. Now that works well for this test scene. Okay, the test scene is located at the origin. With this, anyway, here we have this, and I'll drag that in now, and now it's, now it's going to be in the right spot. And with that, I'm going to go cache and just start caching. Let's just see what happens. And you can see it's starting to churn it up. We need to hide the original cube, and that's quite a lot of force in there because that's using gravity. So this can be quite powerful, and you can obviously animate these on and off as well, and it should take that into account. Okay, thank you very much for watching this video. I hope you found it informative, and I hope to have future updates coming out soon. Cheers.